3D Printing Today, show number 431. How to tell if a 3D printer is selling well. Tuning retraction. Orbiter update.
Welcome back to 3D Printing Today, the podcast about all aspects of 3D printing. Hobby, professional, industrial, doesn't matter. We cover it all. My name's Andy Cohen, and I'm here at Mr. Whitney Potter.
How you doing, Andy?
Doing pretty good. So did you see that story about FlashForge?
I did, yeah. I'm looking at it.
So FlashForge, 3D printing industry put out this article about the Creator 4. And in the opening of the article their headline is basically FlashForge tries to breaks into commercial grade market. I inserted the try because they haven't necessarily broken into the commercial grade market space yet. Now, we don't want to talk about the printer per se here. We're going to do a segment on this printer.
Okay.
But I want to talk about how, this particular market that they're talking about, I don't think that the writer of this article actually understands the market that they're talking about here. This is an IDEX machine, and they called it an IIDEX machine because it's supposed to be interchangeable independent dual extruder system.
Okay.
We'll get into that later in another time. But I just want to look at what is it that FlashForge is really trying to do here, and if they're trying to break into what is the commercial market? There's a market for those companies that do 3D printing, service companies. Mm-hmm. This machine's not for that market.
Mm-hmm. Right.
And there's a market for those who contract and make things like aerospace and defense. This is not a machine for that market.
Mm-hmm. Right.
What this machine could be for, which they don't really talk about, is the same kind of market that others before FlashForge have forged ahead, like Formlabs. Formlabs did their SLA machine on a Kickstarter, and eventually they found their way into engineers' desks. Really, that's the market. Mm-hmm. Somebody who designs or develops or engineers, and these are for examples or test prints or ways to illustrate what they're trying to do. So Formlabs did it. Raise 3D has kind of done it, I think. Ultimaker was very successful at it, and Ultimaker is no longer... These are all machines that started as hobby machines and found their way onto engineers' desktops, and in the process increased their costs to usually between $4,500 to $10,000. Mm-hmm. That's the range.
But increase the quality of their construction and their reliability, although the quality
That's the assumption.
The quality of their prints has not gone up commensurately to the price, though. I mean, the technology is still the same pretty much, right? Yeah,
but I believe that the goal is not necessarily to go faster or necessarily better quality. It's to make it so that it's push button.
And more reliable.
So the engineer doesn't have to spend a penny of their time on it.
Right.
And I believe that's the market that they're trying to get into. Will they be able to pull it off? I guess we'll see. The last time I went to CES, FlashForge stood out for one particular reason. Mm-hmm. They had more printers to present to show what they make.
More different models?
More different models,
different
more different types.
Of the same one? Okay.
Yes. But they had so many that you couldn't tell which one was which, and they dwarfed all the other presenters. Huh. So FlashForge is a force to reckon with. They are probably the premier commercial 3D printing company in China.
Mm-hmm. Interesting. I've still got my original Creator 2 or whatever it was.
It's a Creator 1.
Creator 1?
Yeah.
Okay, yeah. I've still got my original Woody FlashForge, and it still works. I do use it occasionally for things where I got to print flexible filaments because it has a direct drive extruder, and it still works well for that.
Let's call a spade a spade. The Creator 1, and I have one also.
Yeah.
It was a duplicate clone of the Replicator 1.
Right.
They changed a few things like the extruder, and they changed things on the controller board so it didn't blow up the way the Replicator 1 did.
And I changed quite a few things after I got it.
But they didn't do any design.
No.
Very minimal design, just a couple of tweaks and mods here and there that weren't necessarily that great big of a deal.
Right. And I did a fair amount of redesign to get it where it is now. So.
And they were about half the price when they did come out compared to the Rep 1. Anyway, good luck to FlashForge. We will talk about the Creator 4 in a separate segment. In the meantime, what's coming up on our show this week, Whitney?
We ask how to tell if a 3D printer is selling well.
We're going to look at tuning retraction.
And then you give us an update on the Orbitor.
Let's do it. So you ever wonder, is the 3D printer that you got, is it selling? Is it still sell? Is it doing well? Like if you've got like say a CR30. You bought a CR30 and it was a frenzy to get them when they came out. Everybody wanted one. You had to wait. How are they selling today? How do you find out?
That's a good question.
Well, I can guarantee you, if you ask Creality, they will say nothing.
Oh,
they're not going to tell you.
Sure, because they don't want to take away from the sales of their new printer, whatever replaced it, but they don't want to take away from,
well,
they don't want to discourage you either. So.
These producers, these overseas producers are notorious for lack of communication. And they're not going to open up and tell you anything. And they're not going to give you numbers. They're not going to say, oh, we sold 6 million of them. No, they're not going to even bother telling you. They're just going to keep selling them if they're selling. Mm-hmm. But how do you know if they're selling? Well, you can order one, and if there's no wait time, then they're probably not selling that well. They're sitting there.
Well,
but that's kind of guessing.
They've been out for a while, and supply has
and the supply has caught up. So that doesn't mean it's not. You don't get any information that way. I think I've got a way that you can tell if a 3D printer is selling.
Okay,
there is a way.
It's selling currently.
Currently selling, and people are buying it, and there's lots of new users.
Okay,
you find the forum where like getting started new users. Mm-hmm. And you lurk, and if you see posts every day and you see the same questions every day, that printer is selling.
Okay.
If, on the other hand, like you go to the E3D board and you go look at the tool changer forum and you go to the getting started area and there's no new posts,
nobody's getting started.
I think it's a safe bet that sales of the E3D tool changer have slowed to a crawl.
Sure. Either that or everybody who's buying them is just having no problems with them because they're such geniuses.
Well, we know it's not that they're not geniuses. It's just that we know that the tool changer is, by its definition, a machine meant to tinker with. It's a machine that you experiment with and play with. And so if you've got a brand new one, you're going to have questions. You're going to need some collaborative help, some support.
Maybe they're just antisocial.
Or maybe they've done something really cool and they want to show it.
No.
But the fact is the traffic has vanished.
Interesting.
I go up there and I post something, I get 0 replies. Yeah.
Well, maybe there's someplace else where all the cool kids are hanging out and they just didn't tell you.
There is a forum on Facebook. There's a Facebook group called Tool Changers. I think it's Tool Changing 3D Printers. And I've been a member of that group from the very beginning. And there's people up there and they're doing their own builds. And there's nothing in there that's new about the E3D.
Is there a subreddit? There's probably a subreddit. That's probably where they're all hanging out without you.
There's probably a subreddit, but
they're probably talking about you behind your back.
Why would anybody go to Facebook or Reddit or anywhere else when the guy that actually built the machine
has a support forum,
has his own forum, along with the guy that wrote the firmware for it is in that forum? And I mean, you go to where the information is, and unless you've got a brand new Ender 3 and you like screaming to your friends on the Facebook group. So you go to the Ender 3 board and you're going to see lots of people yakking and
I printed a test cube.
This is the way it should be. This is the way it works. Look, it's perfect. It works great. This is the way we should all go. It's like little children screaming back and forth at each other. It's insane, and it hasn't slowed down at all.
Oh, I'm sure they're still selling the hell out of those.
Yeah. Yep. So I think that's telling. I believe that's the way we, as lay people who are not in the industry and have inside information, could see if a 3D printer is selling. And it looks like the CR30 is not selling all that much. Mm-hmm. It's a shame. Oh well. So usually when I try to set retraction, I don't really make that big of a deal of it. It's like, well, I'm at my optimal temperature. I've got steps per millimeter set correctly, sometimes called E-steps. Mm-hmm. And I'm still seeing strings. Well, I don't want to change my temp because I'm getting extrusions as I want them. Mm-hmm. And I'm getting fusion the way I want it to be. And I'm getting the aesthetic of the surface of the print. Because, if you go too hot, you can get little tiny bubbles and it'll start to just change the color.
Right.
And if you go too cold, it could be too shiny or too translucent.
Or you might not get layer bonding.
More importantly, in certain spots, you need to get that layer bonding. You may have a really tight part of your tool path where air does not get in to stop it. Anyway, there's all sorts of reasons for not want to change your temps, but you may want to change the stringing. You may want to get rid of your stringing.
Right.
And the way you do that is you suck the liquid plastic back up the hot end before you move away, so you don't get that string, that smear. Mm-hmm. Sometimes you can't help it because the material that you're extruding is going to string no matter what you do. And I've seen that with PETG. PETG will do that. Some PETG formulations.
Is notorious, and TPU is pretty bad too.
Yeah. So you retract as much as you can. So how do you figure that out? Well, in my previous printers, all I really did was just simply, go a little bit longer length, and I don't change my speed because of my extruder. The speed of your movement is a function of the design of your thermal barrier, or that thermal tube, the heat break, and the size of your melt zone. If you're going too fast, that liquid plastic's going to stretch and squish. Mm-hmm. And the longer you go, the longer that distance, the more that's going to affect how closely you're still within 1.75 millimeters.
Sure. Yeah, and eventually, if you really over retract, then you end up pulling hot, warm, or even hot plastic into your cold zone, and then it's all over.
Yeah, you'll clog it. You're going to clog.
Right, because your drive gears can't push a wet noodle.
Right.
It has to be cold at that point.
Right. So you got to tune it. And in my previous systems, the amount of I never change my speed. And I only change the length, and the amount that I'm changing it is usually less than a millimeter, usually less than half a millimeter, to get something, because I use direct drive extruders. Right. Usually, if you're using a Bowden extruder, you're talking anywhere from 3 to 7 millimeters in length. I mean, I've seen the CME CNC Boss, I think, was 5 to 7 millimeters of retraction length.
Right. Because you've got all of that sort of springiness in the Bowden tube that you have to unload that force first before you are actually pulling anything back. So Bowden extrusions or retractions are much longer.
And that's the reason why I like to use the phrase command authority.
Ah, yes.
Command authority is
command authority.
It's usually used in the flaps on missiles,
right.
and how quickly that missile's going to change its direction based upon the flap and the wind is going past. Well, in our case, it's how quickly you're going to control that liquid plastic coming out of the hot end. And with Bowden extruders, you've got that compression and that stretching that you're dealing with, so you're kind of predicting over time, over certain number of nanoseconds, how it's going to react, and so you've got less command authority. You could still deal with it, you could still get good quality, but you have to figure that out, and you have to tune that. How do you tune that? Well, there are ways of tuning it that are kind of complex. like you can make an object, and you'll see this on Thingiverse. If you Google tuning retraction, you're going to find lots of different approaches where folks, you can literally program in G-code, and I'm probably going to try this. You can use the replace command. If you're using, say, Simplify 3D, you can insert a bunch of replace commands in G-code at the post-processing field in the G-code tab in the process. And you can use the replace command, and assuming RepRap firmware, use the I think it's 407 or 207, one of those, where it sets retraction. And you can say, well, if you're 5 millimeters up, or if you're, no, it's layer number. If you're 10 layers up, replace the retraction command with this retraction command. And so you could do that every 10 layers or so.
And then retraction test.
And you make an object that's basically two sticks sticking up, and you can see the strings, how well the strings work. You could do that for temperature as well. You could use that same approach for pressure advance or jerk to test how well your extruder will work, and then you mark or some indication where you are in that path to see how well you're performing on that object. That's kind of a pretty time-consuming way of doing it, but you'll get it exactly as you want it. It's pretty specific.
Yeah, just save that G-code, because that G-code is quite specific to your printer, so you can download, there's a lot of objects that have been made on Thingiverse, and some of them are cute. I mean, like if you got like the temperature ones, it has the different temperatures like printed into the different levels as you're going, but the object itself can't contain that temperature change information. You have to add that in yourself after you've sliced it, which makes it a little bit trickier. The temperature ones are pretty easy to do because you're just setting the, it's like an S, whatever the command is that you're using to set the temperature. Those are pretty easy to find and just change manually.
Yeah, the tricky part of doing it putting this much work into it, though, is that, that's going to change per material, too. Not only change per material, but change per color. So it's still PLA from the same company, but it's a different color. Well, I've got 4 of the same companies. I've got white and red. They completely different retraction. Because one's streaming out strings way more than the other.
There's a little bit of difference in the engineering qualities just by changing the pigments.
So for me personally, it's my opinion. I don't do my retraction settings in firmware. I do them in my slicer, and I look at the performance of that material for that object, and I change that setting in the slicer. But, what's really cool is you can change, if you don't do it through the slicer, you do it through firmware, you can change it on the fly. You can do it in the console. So it depends upon how you like to do your 3D printing. For me, though, my preference is get it down right for that material on that object, and just go with it.
Yeah, my preference is just have a set of settings that when I tell it to print something, it prints it. It may not print it as fast as it possibly could, but it's reliable.
And if there's strings, you just clean them off.
Yeah, they're very easy to clean off. You have to have a really bad settings so that you get enough strings that you can't just clean them off.
Yeah. So it's time to do an update on the Orbitor V2s that are in the tool changer. Initially I had some real problems, and the problems were the Orbiters performed brilliantly. The Orbiters, for the extruder motor on the Orbiters can be set your jerk and acceleration to extreme high performance settings. That is, they're saying in the specs for the Orbiter that your retraction speed should be 90 millimeters per second. That's pretty
darn fast, yeah.
And that means it's going to go. So you don't want it going very long. Because remember, the Orbitor is just the feeder component of the extruder system. And so the feeder can go super quick from 0 to its maximum speed, and they're saying it's 7,200 millimeters per minute.
Okay.
I think. Yeah, and they say you can set acceleration to as high as 10,000. Now, you're never going to get to the acceleration with the length of.
You'd have to have a very big printer.
It's ridiculous. So acceleration is
rev up.
It's kind of not really an issue here.
Yeah.
Jerk is a bit of an issue, and jerk they've got it set so that it's like switching really quick, going from 0 to its maximum really, really fast. But the maximum length that the ideal length that they want you to use is 1.2 millimeters. Mm-hmm. So when you pick the Orbitor V2, you should consider the rest of your extruder. And maybe I didn't do that. I looked at, I'm attaching these to good old fashioned E3D V6s.
Right.
And while you can set things so that they work together well, they're not going to work together well if you've got the Orbiter set at its maximum performance, because the distance of the melt zone for the V6 assumes a less performing Bowden system. And if you're zapping the filament in and out really fast, really long, or long as in longer than 1.2 millimeters, you're likely to get a clog. And I did. I was getting clogs. So I had to bring those performance things down a bit and make the length of retraction much smaller. And I'm still tuning that. And we'll get to how we can tune them. Should we talk about that here? We'll talk about tuning those things in another segment. But they're working great. The other challenge is setting currents. Now, current settings on the smaller motors is actually kind of tricky, which is probably why we did not see the smaller stepper designs in earlier motors. And I'm finding it, I'm either too hot or not enough torque.
Right. They barely put out enough torque if they're tuned perfectly, which is why I think that the NEMA 17s were a more popular design.
Right. And that's why I believe E3D did not use the small stack pancake stepper motors for the 40 millimeters for the Hemera, because I believe they could not get the torque per current settings that all of the firmware out there can do. Now, so I started tuning my firmware current. I was tuning the RepRap firmware for the optimal current, and I would check that by putting the palm of my hand on the surface of the motor. And at, the standard RMS they say is 850. Well, at 800 milliamps, I could not get it to not stepper stutter.
Right. So not enough torque.
Right. So I said, well, let's do 850. Well, you can't. In the RepRap firmware with V2 mother controller board, Duet, you can only set your motor drivers per 100 milliamps. It will so round up
800 or 900.
Right.
Milliamps,
so 850 goes to 900 right away.
And that's too much.
Well, 900, it's as hot as the stepper motors on the Replicator too. Okay. So if I touch it with the palm of my hand, it's hot. It's not going to burn me, but it's hot.
Yeah, that's okay. As long as it's not hot enough that it's bleeding into the tool path.
So it's okay. Yeah. But I still, every now and then, I'm hearing it stuttering. Everything's printing okay, but I'm not getting optimal current setting. And more importantly, I'm seeing a faint vibration pattern under certain light conditions for certain planes of extrusion. And that's what we saw with the old, what was the company, Type A machines, the second version of their printer.
Yeah.
There was a faint pattern that nobody could get out. Well, guess what? They used a smaller stepper motor.
NEMA 11 or something.
Yeah, and there was no way to monkey with the current on their firmware, and nobody was able to get that pattern out. And that did not bode well for that company. And I'm in that same situation right now with the version 2 of the Orbiters. And my controller board, I can't tune that little tiny vibration out. I can't get to an optimal current setting. When we had the pancake steppers on the Race 3D N2, we had the old style drivers, motor drivers, where we can go in there with a screwdriver and a voltometer,
Right.
and we can tune it to whatever. There was no bumping up or bumping down. These motor drivers, that's not the case. Now, DC42, also known as Dave Crocker, tells me that the version 3 of the Duet board, the resolution of the driver current
It'll be higher.
is like, I think, 25 milliamps. But hey, you know, I've got the older board in there, and that's what I'm going to be using. I'm not going to change my motor board because
Just
of
for
this.
that.
I'd rather change the extruders than change the motor, the controller board. Anyway, so it's getting a little complicated. I'm probably going to live with 900 milliamps for now, but we're certifying this machine. We're still testing it with benchies, and eventually we'll be doing larger multi-day prints, and we'll see how well it performs.
Sounds good.
Oh boy, Whitney, another show written to the hard drive, waiting for encoding, uploading, and commitment on our feed. To all of our very supportive listeners, thank you all out there for your support on Patreon. Thank you for your positive reviews, wherever those reviews can be made. Thanks for those write-ups. We do appreciate those. And thanks for listening. We do it for you. We do it for fun. Currently no advertising. You know, I keep getting emails from so many people because we're way past the criterion for ads. We've blown right by it. And I keep getting emails from people saying, "Oh, will you interview my CEO?" And would you talk about our product? And you know, I usually don't reply. But if you are out there and you're scratching your head thinking, should I bother? Yeah, sure. Go right ahead. You never know. It may be something worthy of our discussion at the very least.
Yeah, but we don't do a lot of interview segments except at trade shows and stuff. So.
Yeah, and maybe someday in the future there's a MRF or an ERF we will go to. Not this year coming up. I got plans, but maybe next year.
Yep.
In the meantime, I do have a thing of the week.
You do.
I do. This is the can holder that comes to us from a Thingiverse user whose handle is Dawnbringer6.
Otherwise known as Nicholas Kurgan from the US of A.
Now, this is a relatively simple print. I was able to print this without any supports. I did it in NGen, which is a formulation of PET. I wouldn't recommend this in PLA, ABS or PETG probably, because it's going to have to hold a can. It's a really nice handle. It's a method of you put the can in, and if you like to drink really cold soda or beer, this is perfect.
It keeps it cold.
Keeps it cold, and it feels like you've got a mug in your hand.
Oh, there you go.
Really, really cool.
And it's very cool looking. It's a very, very elegant design. So.
Yes. And we did print this with the camera on, so we do have a time lapse of this on the tool changer, although it's only one material. It was an experiment. So we may get this vid out there.
Sweet.
Speaking of time-lapse vids, we are probably going to start doing time-lapse vids as a regular thing related to the show. We've already got a couple out there. If you go to YouTube and search 3D Printing Today or search time-lapse videos or Toby C. Wood, one word, you should be able to find us. We'll also have the references in each of our show postings on our forum or on Facebook that has the URL for the YouTube vid in there. So watch for those. So we will have one of this particular thing. If you've got a tip, a question, or a candidate thing of the week, what are you waiting for?
Send us an email. Send it to info@3dprintingtoday.com. That's THREE, the letter D, printingtoday.com.
And we do have a show next week, show number 432.
We do. Let's see. We have a first look at the E3D Revo.
And then we'll be printing a color 3D Benchy.
Wow. And then we talk about prusaprinters.org.
Which, by the way, they changed the name already.
They did already? Okay.
Yeah, it's now called printables.com.
Oh, okay. Well, that's better. It's catchier.
I think so, too.
Yes.
I think so.
Anyway, it's Prusa's version of Thingiverse. It's their printable thing repository. So.
Yes. And I think that's it.
Great. Thanks for listening.